In the crucible of World War II, humanity unleashed technologies that redefined warfare and reshaped the globe. From the roaring engines of revolutionary aircraft to the silent, unseen currents of coded messages, this was a conflict where innovation was not just an advantage, but a matter of survival. We revisit the groundbreaking advancements that turned the tide and laid the foundations for the world we know today. The year is 1939. Europe stands on the brink. The shadow of Nazi Germany, armed with a resurgent military, looms large. The Maginot Line, a symbol of perceived invincibility, would soon prove tragically inadequate against a new, mechanized form of warfare, blitzkrieg. The stage was set for a global conflagration, demanding unprecedented leaps in technological might. The war in the air was perhaps the most visible testament to this technological arms race. The British Supermarine Spitfire, with its elliptical wings and powerful Rolls-Royce Merlin engine, became an icon of aerial defense during the Battle of Britain in 1940. Its speed and maneuverability were crucial in fending off waves of German Luftwaffe Messerschmitt Bf 109s. Conversely, Germany's Messerschmitt Bf 109 was a formidable adversary, and its counterpart, the Junkers Ju-87 Stuka dive bomber, instilled terror with its distinctive Jericho trumpet siren and precision attacks. These aircraft represented the cutting edge of aerial combat design, pushing the limits of aerodynamics and engine power. The Battle of Britain, fought from July to October 1940, saw over 1,000 German aircraft launched against the United Kingdom. The Royal Air Force, despite being outnumbered, utilized radar technology, developed by scientists like Sir Robert Watson-Watt, to detect incoming raids with remarkable accuracy, a critical factor in their ultimate victory. Beyond fighter planes, the war saw the rise of the strategic bomber. The American Boeing B-17 Flying Fortress, a 4-engine heavy bomber, conducted long-range daylight raids deep into enemy territory, targeting industrial centers and military infrastructure across Europe. Its robust construction and defensive armament made it a symbol of American air power. In the Pacific theater, the Japanese Zero fighter, despite its lighter construction, offered incredible agility and range, initially dominating Allied air forces. However, its vulnerability to damage and the gradual introduction of more advanced Allied aircraft, like the Grumman F-6F Hellcat, began to shift the balance of air superiority by 1943. The development of jet propulsion, though in its infancy, promised a future of unprecedented speed. Germany's Messerschmitt Me 262, the world's first operational jet-powered fighter, entered service in 1944, demonstrating speeds far exceeding its propeller-driven contemporaries. Allied nations were also rapidly advancing their own jet programs. Naval warfare was equally transformed. The aircraft carrier replaced the battleship as the dominant capital ship. The Battle of Midway in June 1942 was a turning point in the Pacific, where American carrier-based aircraft inflicted a devastating blow on the Imperial Japanese Navy, sinking 4 of their crucial fleet carriers. Submarine warfare posed a grave threat to Allied shipping. German U-boats, particularly the Type 7, prowled the Atlantic, employing wolf-pack tactics to sink Allied convoys. The development of improved sonar, depth charges, and code-breaking efforts, like those at Bletchley Park deciphering the Enigma code, were vital in combating this threat. The Enigma code, a complex cipher used by the Germans, was a constant challenge. The Allied success in breaking it, spearheaded by Alan Turing and his team at Bletchley Park, provided invaluable intelligence, significantly shortening the war and saving countless lives by revealing U-boat positions and enemy plans. Incredible advancements were also made in weaponry. The development of the atomic bomb under the Manhattan Project, culminating in the Trinity test on July 16, 1945, in New Mexico, marked a terrifying new era. This weapon would ultimately bring the war in the Pacific to a swift, albeit devastating, conclusion. Conventional artillery and small arms also saw significant evolution. The German Sturmgewehr 44, introduced in 1944, is often considered the first assault rifle, capable of selective fire and using intermediate cartridges, revolutionizing infantry combat. Its design influenced future firearm development profoundly. The war spurred innovations in rocketry, most notably Germany's V-2 rocket. Developed by Wernher von Braun's team, this ballistic missile, first launched in 1942, was the precursor to modern space rockets and intercontinental ballistic missiles. Its sheer range and destructive power were unprecedented. Logistics and transportation were critical to sustaining the war effort on a global scale. The development of synthetic rubber, advancements in mass production techniques, and the standardization of parts were essential for supplying vast armies across continents. The Liberty ships, built in American shipyards, were crucial for transporting supplies across the Atlantic. Medical advancements were also significant. The mass production of penicillin, pioneered by Howard Florey and Ernst Chain, saved countless lives from infections that would have previously been fatal. Blood plasma transfusions became more widespread, improving the survival rates of wounded soldiers. Communication technology played a silent but vital role. The development of radar, as mentioned, was critical for air defense. Radio communication, improved throughout the war, allowed for coordination between widely dispersed units, although Allied code-breaking efforts were perhaps the most impactful technological communication tool. The American M1 Garand rifle, adopted by the U.S. Army in 1936, was a semi-automatic rifle that provided American infantry with a significant firepower advantage over the bolt-action rifles used by many of their adversaries. Its reliability and rate of fire were legendary. In the Pacific, the island-hopping campaign relied heavily on amphibious assault vehicles. The Higgins boat, designed by Andrew Higgins, was instrumental in landing troops on heavily defended beaches, such as those at Normandy on D-Day, June 6, 1944. Its shallow draft allowed it to approach shorelines effectively. The war also saw the development of early computing technologies. The Colossus computer, developed in Britain, was used for cryptanalysis of the German Lorenz cipher, a more complex code than Enigma. This marked a significant step towards modern electronic computing. The German Tiger I tank, introduced in 1942, was a feared adversary on the battlefield. Its heavy armor and powerful 88mm gun made it a formidable opponent, capable of destroying Allied tanks at ranges far exceeding their own gun capabilities. However, its complexity and low production numbers limited its overall strategic impact. In response, the Allies developed tanks like the American M4 Sherman, which, while less heavily armored than the Tiger, was produced in vastly greater numbers and proved highly adaptable and reliable, forming the backbone of Allied armored forces. The deception technologies employed were also ingenious. Operation Mincemeat, for instance, used a corpse dressed as a British officer carrying fake documents to mislead the Axis powers about the Allied invasion of Sicily in 1943, demonstrating the crucial role of intelligence and psychological warfare. The war's end in 1945 marked not just a cessation of hostilities, but the dawn of a new technological age. The radar systems perfected for detecting enemy aircraft became the basis for air traffic control. Jet engine technology paved the way for commercial aviation and space exploration. The principles behind the V-2 rocket led directly to the space race, with the United States and the Soviet Union competing to reach orbit and the moon. The atomic age, born from the Manhattan Project, ushered in an era of both immense power and existential threat, shaping geopolitical strategy for decades. The sophisticated communication and cryptography developed, particularly the efforts at Bletchley Park, laid the groundwork for modern computing and the digital revolution. The very concept of information warfare and cybersecurity has its roots in the desperate battles fought with codes and ciphers. World War II was a brutal, devastating conflict, but it was also an unparalleled engine of innovation. The technologies forged in its fires did not just determine the outcome of battles, they fundamentally altered the course of human history, influencing everything from the way we travel and communicate to the very nature of global power. The echoes of these wartime marvels continue to resonate today. What other overlooked innovations from this era quietly shaped our modern world? Join us next time as we delve into